Okay, good morning everybody. So we are going to lecture on chapter 3, and this is still really just getting off the start line. How to set up Visual Studio, how to work with the tool set, right? So, if our carpentry class is still like we're studying the hammer. We're not really quite building homes yet. And we might start, tacking some wood together today. But it is very introductory in the sense of what we're doing here. So let's go ahead and open up Visual Studio Community 2022. And I'm going to go through the process. I already have a Chapter 3 solution created. If you don't have a Chapter 3 solution, just as a reminder, you would click on this Create a New Project button. And there's two templates. There's Console, which are your command line, and then there's Windows Form App in the .NET framework. And this is referred to as a GUI, almost like gooey butter cake, but spelt G-U-I, pronounced GUI. Graphical user interface. And then what we do here is in the location, we select the lab folder. Notice at the end here, at the end of my location, I have this lab folder selected. And that just simply means, okay, inside the lab folder, our solution name, we match the name of the subfolder, like CH02, CH03. So if you haven't done this yet, the solution would be CH03. And it would just, again, you're matching the name of the subfolder, so it puts all the files in that subfolder. So we're in the lab folder, and then the solution is CH03, and then your projects, you would just name them like Exercise 1, or Lab 1, or whatever it is, Demo 1. Okay, and that's kind of how you get started with Visual Studio. Now, I'm not going to do this because I'm going to go back. I've already created the Chapter 3 solution in my demonstration last week. So since I've already created it, I'll just click it. And keep in mind, all your files exist inside of this tab called Solution Explorer. So a lot of times, you open up a solution and then students get to this screen and they're like, I don't see anything. I don't know where my code is. Keeping in mind that you have to open up this Solution Explorer tab to find your files. And if you want to pin, there's a little pin right here that'll pin your solution. Now looking at my Chapter 3 solution, I've got a couple of council apps. Okay, of which we're not writing councils in this chapter. This chapter we're writing, as I said, GUIs. So what I'll go ahead and do, since I've got two projects, neither of which are GUIs, I'll just create a new project. And I'm just doing this for demonstration purposes. You don't have to follow along, but you're welcome to. So to add a new project, if you remember, you're going to right-click the solution and say Add a New Project. And I'll go off my GUI template and I'll just call this like lecture demo. Click on create and we get a nice little form. Okay, drag and drop. Now keep in mind the startup project is up here in this drop down. So if I want to run this GUI, I have to select the project. In this case, I called it Lecture Demo. And then you run it off of the debug menu. Debug, start without debugging. Right? All this coming back to you guys after a weekend? You've seen this all before. And now I've got the form running, and that's how you get started. So now, looking at our objectives here, it does look like we're going to get into writing a little bit of code. So in my analogy, you know, if last week we studied the hammer in carpentry, this week we're going to start tacking some wood together with some nails. And what I mean by that is we're going to start writing some code. So we're gonna add some code. We're gonna test an application. We're gonna talk about coding style a little bit. You know, we talk about convention. We talk about variable naming convention last week. But there's also a little bit of style that can be done to make your code easier to read. And so it just boils down to, when you write code, it's called your source code. And you want your source code to be easy on the eyes, because we're working in source code 8 hours a day. You want it to be easy on the eyes. You want it to be easy to read. We started using comments last week. We'll introduce how to write comments. And then, of course, there's help features. They go through Chapter 3. Look at this objective. In the context of object-oriented programming, describe these terms: class, object, instantiation, instance, property, method, event, and member. So in this chapter, there's a bunch of concepts, a bunch of programming concepts that we're going to take a bird's eye view of. We're going to be introduced to these terms, and we're going to try and get a very high-level understanding of these terms, because throughout the rest of this course, we go into a deep dive on these terms, right? So this is kind of like a bird's eye view on some programming concepts so that you can get exposure to them. And then throughout the rest of the course, we go in deep and we expand on all of these programming concepts. So we'll just call this the bird's eye view of some programming concepts. We'll go into some event handling, code snippets and refactoring, the different kinds of errors, syntax errors versus runtime errors. We kind of saw some different syntax errors last week when you got the red squigglies. You know, that's an example of your syntax error. There's a little bit difference between testing and debugging. A good distinction between what is testing, what is debugging, and then something called a data tip when debugging runtime errors. So we saw last week how to create a form and drag and drop controls, and so what we're looking at here is a bunch of text boxes. Some of these text boxes I can tell are read-only, right? Because they're grayed out and the end user can't type in them. Sometimes you could do a read-only text box, or you could just do a label. Like, labels are naturally read-only, so you know, a couple different ways of doing the same thing. So we got some labels on the left, we got some text boxes on the right, we got a couple buttons down below. And so right away they hit us with the programming terms. Oh my goodness. Okay. I always like to talk about why things are important. Why are these programming terms important? And what we're diving into here is what's known as object-oriented programming. In short, they call it OOP. Before object-oriented programming, I would say this took hold in the 90s with Java. Before object-oriented was so popular, there was something called procedural programming. And these are known, these two things, object-oriented versus procedural, which, by the way, nowadays there's also another type. They call these programming paradigms. what I'm listing here, spell that right? Paradigms?
You got a G down. Yeah.
Oh, did I miss it?
Yeah, MS.
These are programming paradigms. These are ways that software is built from the ground up. These are programming paradigms, ways that software are architected, coded, developed, tested. Procedural programming was around for a long time before the 90s. And in procedural programming, you had really variables and functions. And those were the two things that procedural programming had. But what happened frequently in procedural programming is you had a lot of repetitive, I cannot spell. You had a lot of repetitive code. And what was called spaghetti code. Spaghetti code, imagine spaghetti, a bowl of spaghetti. What is spaghetti? It's just going all over the place, right? And so the following the code and understanding what's going on becomes very hard when you're looking at a bowl of spaghetti. Okay? So procedural programming had these two very problematic aspects. Lots of repetitive code. You'd write the same code over and over and over. And it was very hard to follow through and troubleshoot and fix problems. Right? So you'd have a problem and you were tracing your code from line 5 to line 100 to another file to line in, and you're just tracing it through this spaghetti. Okay, so procedural programming, and in the 90s, out comes this new paradigm called object-oriented programming, and this was the golden goose. Object-oriented programming was the savior, right? This new paradigm, this new way to code, okay? But it's completely different than procedural. It's very different than procedural, okay? And if you weren't ready to update your skills and you weren't ready to learn object-oriented programming, you probably lost your job. You know, there were a lot of companies that transitioned from the old paradigm to the new paradigm, okay? And so procedural programming had some problems. Object-oriented programming solved these problems. Okay? You were trying to not have repetitive code. Okay? And not have spaghetti code. Okay? So a big feature of object-oriented programming is the idea of just they gave it an acronym. You might have heard it before. It's DRY, D-R-Y. Don't repeat yourself. So you're writing code once and you're not repeating yourself. Okay? And the idea of like writing code in reusable chunks. Okay, so you write the code and you reuse it, and smaller reusable chunks. Turns out when you're writing small reusable chunks of code, it's much less spaghetti-like. You know, hey, I'm just troubleshooting 50 lines of code or 30 lines of code. It's not as difficult to follow, right, or troubleshoot. Okay, so as human beings, we solve big complex problems one step at a time, right? And it's easier when you have a smaller thing to troubleshoot and fix and look at. You know, it's easier to fix. Okay, so just going through the history there, procedural programming then went into object-oriented programming in the 90s. Object-oriented programming is still a big thing today. There's another paradigm called functional programming. that's kind of, I don't know in relation to object-oriented programming. I don't think it's nearly as big. But functional programming is kind of on the map now in 2020. Okay, and so a lot of people write JavaScript in a functional programming manner. Okay, JavaScript itself is kind of a hybrid of these paradigms. Okay, so JavaScript doesn't follow any one of these. Okay, JavaScript is a little object-oriented. They call it object-based, and it can be functional as well. Okay, so all that just to say, object-oriented programming solves some coding problems. With Java, C# as a language is kind of as if C++ language and Java had a child. If C++ and Java had a child, you know, that is C#. Okay, and so if and when you study Java, you're going to go, oh, that's very similar to C#. Like I kind of know Java. You know, you kind of can be familiar with a lot of Java just by knowing C#. So when we're studying these terms, class and object concepts, these terms are object-oriented language features. Okay, these are not unique to C#. These are not unique to C#. These are just any object-oriented language has these features. And the first couple of terms apply directly to what I was just explaining. And I want to point you to the class, the word class. When I was first studying object-oriented programming, the language that was used in the book that I studied was that a class is a blueprint of an object. Okay, now I don't know what a class was, I don't know what an object is, but I memorized that. I thought that was important. A class is a blueprint of an object. And so I know what a blueprint is. I know what a blueprint is. In fact, I knew what a blueprint was when I was pretty young, because in my neighborhood where I grew up, I don't know if you guys were like me, but in my neighborhood where I grew up, if I'd go over to my best friend's house and I'd go in their house, I would see, man, your kitchen is exactly where my kitchen is, and your bedrooms are exactly where my bedrooms are. And so it turns out that the architect of my neighborhood reused a lot of blueprints. And so his house was laid out just like my house, right? The idea is you make a blueprint and then you create a lot of the same things out of that blueprint, right? So my house was one instance of a blueprint, and my friend's house was another instance of a blueprint, right? Does that make sense, right?
Yeah.
I see some people nodding their heads like you probably could relate to that, right? In software, it's the same thing. Your class, anytime you see the word class, that's your blueprint. A class is your blueprint. But what are you creating? In the real world, I said you created a house. Well, in software, you can create anything. Whatever thing you want to create, you're creating a digital version of a real world thing. So an object is a generic term. It's very generic. All an object is a computer representation of a real world thing. Think of a noun. A noun is a person, place, or thing. So an object is a computer version of a real world thing. So these are object-oriented concepts. Your class is your blueprint of that thing. So if I want to represent this chair in my software, okay, I'd make a class for this chair. Okay, it would be called chair. The class is called chair. And classes have two defining features of classes. So our blueprints have really two main parts. So again, I could make a class of chair. I could make a class called student. Remember, class is the blueprint. Class is the blueprint. If we're going to make a bunch of students in our software inside Rankin, if I'm going to make a bunch of students in our software, like inside Rankin has a bunch of students, I need to first define what a student has. Okay? What are the attributes of a student? Okay? Students have first names. That's an attribute of a student. Last names. You all have student IDs. Right? What other pieces of information does Inside Rankin store about you? I don't know, an email address. Students have email addresses. Probably, somewhere in there, your gender. Maybe something about your financial aid status, like approved or not approved, you're paid or not paid, something like that. So again, classes are your blueprints of objects. Objects are just real-world things that exist in your software. It's a generic term, right? Object, and it's a thing. It's an object. And that's the foundation of, remember I said these things solve some of the problems like repetitive code. You make a blueprint and then you just reuse that blueprint. So you're reusing code. Once you create a student blueprint, a student class, you reuse it, and you don't have to repeat so much code. Yeah.
So you have the class, and then the object is just in the class.
The object is not in the class. So think of it like this way. If the class is your blueprint, like think of the blueprint as for a house, right? My house is one object. Your house is another object. So each instance of the blueprint is an object. Does that make sense?
Yeah.
You sure?
Yeah.
Each instance of the blueprint is an object. So look at the third. An object is an instance of the class. Remember, the class is the blueprint. Does that make sense?
Yeah.
Vinny?
So the class is just like characteristics. So like for the house example, like
Yes.
one of his characteristics might be like, you have blue walls, but your walls might be purple.
Yes.
Is that like what you're getting at?
Yes.
Okay.
Because the attribute is wall color.
Mm-hmm.
But each instance of a house could have different wall colors,
Different attributes.
different values.
Okay.
The attributes are the same. The attribute is the wall color.
Yeah.
Yeah?
But the value of that.
But the value of the attribute is different. They can be different or they could be the same. We could both have blue walls. Okay? Good, you're thinking. Now, fundamental stuff here. Again, we're looking at a bird's eye view. This is all semester long. We got all semester to learn this stuff. This is bird's eye view of this stuff. Okay, it's the first time you're hearing it. I see some wheels turning. It's Monday morning. It's really good to get wheels turning on a Monday morning. So that's good. Your blueprints of your things have attributes. Like your home might have a wall color attribute. Your student might have a first name attribute. So attributes are one key component of classes. The other key component, there's two. There's two key components. Classes are made of two things, very broadly speaking. Broadly speaking, classes are made of two things: attributes and behaviors. What our things can do, right? So as a student, what can a student do? Just as an example, you could enroll in a major. You could enroll. What's the opposite of enrolling? Dropping, right? You could drop a major. Maybe a student could make a payment towards their financial aid. Maybe a student could the point being, behaviors. So your classes have two important, broadly speaking, members. These are called members. Class members are your attributes, the pieces of data, and the behaviors, what they can do. Okay, so data are your attributes, and behaviors are your what the thing can do. So students could enroll. If I was making, if I'm going back to my chair example, I would make a class called chair. Chair color would be one attribute. Right? What can this chair do that's relevant to my software? Well, this chair can raise, it can lower, it can roll. Right? These are behaviors. What can these things do? Okay? See if I got any questions on Discord. Discord's going all right. So the attributes, yes, Ryan.
Since there's two components in classes, you said one of them was behaviors, and what was the other?
Attributes. Yeah. Now, behaviors from a programming standpoint, that's called your methods. Right? So behaviors or methods. Attributes are also called properties. So you're going to see these many times. There's multiple terms meaning the same thing. Okay? But when I say attributes, properties, behaviors, methods. There are also what are referred to as events. An event just means something important that happened in the software. So broadly speaking, you could say that an event would fall underneath a method. So I loop them together, but you could separate them out and say that an event is a kind of method, very technically speaking. However, you could loop them out and say, okay, there are properties, methods, and events. All three of these things together are called members. So a class has members, and these are just the things that belong to a class. Again, a class is the blueprint of a thing. An object is a single instance of that class. Classes have, broadly speaking, two components. The first component are your properties. The second component is called a method. Pieces of data and behaviors. Kind of a little bit more narrow scoped, you could say, okay, well, technically an event is an occurrence. Something happened that was interesting to the software. So you could kind of broadly say there's two types of members, but here they actually narrow it down to three types of members.
What were you talking about, like, whenever you were saying members?
A member is basically what belongs to a class. That's what a member is. What belongs in a class. And these three things right here are your members. Properties, methods, and events. And Vinny, this is kind of the answer to your question earlier. If you read this bullet.
Okay.
Right? Wall color is the same property.
Mm-hmm.
right? But the actual value of the wall color might differ from house to house.
So it all comes from the same instance.
They all come from the same instance, exactly right. So student is the class called student. Each one of you has a unique value for your first name. Now maybe some of you, Sam, you have the same first name. But maybe not. Maybe one's Samuel, one's just Sam. Right? It can be the same. They don't have to be the same. The values can be the same, but they certainly don't have to. So as it turns out, when you're dragging and dropping from the toolbox onto your form, you're actually doing just that. You got a text box. You're creating an instance of the TextBox class. And you're giving that instance an ID. You're giving that instance a name. Remember the properties box? You're setting all the properties for that particular text box. Right? So then the behaviors, or maybe we'll call it specifically the events, right, could be whenever the text is changed, whenever the user changes the text in the text box, that could be an event. You could cause code to run when the user changes text in the text box. So point of this slide being, it turns out that when you're dragging and dropping things in Visual Studio, a lot of code is generated for you and kind of coded in the background that you don't really see unless you go digging for it. And in the code editor, like if I could just drag let's see, if I just drag a text box onto this guy here and I view the code, we've got some drop-down items here. So it turns out what we're looking at, this first drop-down list, like if you're curious what these drop-downs are, that first drop-down is the object. The object is the lecture demo form. And so if you've got multiple objects, you might see multiple things here. The lecture demo form 1, that's the property, that's the name property. So that's the second one, these are the properties of the object, and these are the methods in the third, right? So what we're looking at here as we code more and more, you'll see that in the drop-downs. So these two drop-downs here, these are both members of our object. The members being the properties and the methods. So you can kind of just understand what you're looking at here a little bit more. If I save this, let's see. Now, remember the properties windows? Like my properties window is not being displayed. It's actually over here. It's collapsed. So if I pin this, it'll go underneath Solution Explorer. Remember last week we went through and we gave this a name, text, username. Just a little foreshadowing. When I'm in this properties window, this button right here, can everyone see where my mouse is? Remember, there's members are your properties and your events. So this button, these are the properties of the text box. But you see the lightning bolt? The lightning bolt is the events for the text box. Remember, an event is a kind of a method, right? So these are the different behaviors, like when you enter, like if I wanted to code an event for an enter, like basically when the control receives focus, when you enter and you get focus, you can actually double click. Watch what happens if I double click right here. So I've clicked the lightning bolt, and if I double click right here, it'll generate what's called an event handler. This event handler is a method called text username enter. And then I could write my code right here to run whenever that control receives focus. Just to kind of flush that out, maybe I'd put a label in here. Label. And again, the lightning bolt, these are the events of the label. And this button with the wrench on it are the properties of the label. So I'm going to go back to the properties. I'm going to get rid of the text. And give this a name of label LBL result. Remember that I wrote code on a enter occurs when the control becomes the active control on the form. Basically when it receives focus. So I'm just going to add another text box so that it doesn't have focus by default. And I'll set if I click the form, remember I want to set the tab order so that this one receives focus first, this one receives focus second, and then it doesn't really matter about the label. So when I launch my form, you can see that this one has focus first, where the cursor is. Okay, so now I'm going to write some code. Whoops. Now I'm going to write some code, take the tab order off, just to run a little bit of code. Come on, tab order. This thing's always hiding on me. There it is, tab order. Okay, I'm going to write a little bit of code here on the text username enter. Label result.text equals focused on the username text box. Okay, so I'm just gonna show you that when that control receives focus, it's gonna update the text property of the label to say focus on the username text box. Okay, so I launched the program, nothing's there. Once I hit tab, you see it receives focus, that code runs. Straightforward enough? So again, main thing there, properties and events. Those are your members of the objects.
So what was the event that was there? It was you tabbing onto the text box?
Yeah, so the event, if I click on this text box and then I click on the events window, it was the enter event. And it even gives you a little description right here. Occurs when the control becomes the active control of the form.
So it's not like when you click enter, it's when you tab on.
That's right. It's not clicking the enter button.
That's right.
That was, you know, you got the accept button on the form. That was another kind of,
Oh, okay, I see.
yeah. Yeah, so that was more around focus. And so you could tab it, or you don't have to tab it. It could also, either way, as long as it gets focus, I could click it. All right. We're at a good pause for a break. We could have been going for about 40 minutes. Let's go ahead and take a break. I'll pause the recording. Went ahead and resumed after a break. Left off right around here when we got done looking at the different members in the drop-down boxes in Visual Studio. You'll also notice that the members, like for example here, when I when I type in the ID, right? So my label, I've got a label on my form that I gave an ID. So by the ID, the actual property is the name property, not the ID property. So I call it label LBL results. So the name is LBL results. So in code, I can reference LBL results. So the name property on the GUI side, you can reference it in the code by its name. So as I'm typing LBL result dot, you also see all of the members here. And so you can kind of see the wrenches, the icon there. Those are going to be your properties. The little cubes there, those are your methods. Like you can tell it to have focus. And so it would be coded as something like this. And so that causes a behavior to occur. Label result dot. So these cubes are behaviors that you can cause to occur in code. You could tell, hey, when the user submits the form, if there's an error, then you want to focus the field that has the error, right? So you've probably done that on websites a bunch, right? You fill out a form, you forgot something, you click submit, and all of a sudden the cursor goes to that text box. It focuses the text box that you forgot to fill out, right? So that's the cube, but then also the lightning bolt, as you might remember, the lightning bolt are the events. So you could also cause events to occur. Point being, you follow by the name. It's the name dot, so it's kind of the notation. It's called the dot notation. The name of the object dot the member. Object name dot member name. That's the case most of the time. Is this syntax right here? Object name dot member name. Okay. Occasionally, instead of referencing an object by its name, you reference it by its class name. So for example, we had a student class in our discussion. You would say student dot member name. And occasionally you use this syntax. We don't really need to dive into when is what. But most of the time, though, I will say it's object name dot member name. Okay, that's the syntax most of the time. There's these things called static methods that we'll get into that you code them a little bit differently. Okay, and so one method would be the focus method. We kind of showed that. There's also a close method that you can do on the form. Just quick demonstration of the close method. This dot close. And so this dot close, let's see, you see it closes the form. So this dot close is your how to code, basically closing the keyword this refers to the form. So it's basically closing the form. Yes, sir?
So why is it this and not LBL result or whatever you have it as?
Yeah, you might be able to code it that way. The keyword this is just a keyword that references the form. And so this currently is called, let's go to the name of our form. Sometimes digging through these properties, just called form 1. So form 1, dot, there is no close method on the form 1. You know, I've always just coded it. I've never thought that through like that. That's, I mean, that's a valid question. So you can see here, this refers to form.close, and there's your answer.
Okay.
You can kind of see as I code that. Let's see. Let's see. When I said this dot, you could see it's a form.close, which, remember I said there's two ways to call a method. This happens to be a static method. Close is a static method. So instead of calling it by object name dot member name, it's actually the other syntax, which I covered, class name dot member name. And so implicitly what happens, this refers to form dot member name is close. And you can kind of see that the way I saw that when I typed this dot, you see this little box right here? It's form dot close. Remember, form is the class name. So a more concise answer to your question is that sometimes we have these things called static methods. Static methods are called differently than non-static methods. And the close is a static method. So it's coded a little bit differently. All right, we covered slide 11. Okay. When I coded this method, remember I went to this lightning bolt, I clicked on my control text username, I click on the lightning bolt, and what I did was I just double clicked the text box. Like, for example here, I can single click and it doesn't generate an event for me. Notice the cursor is just hanging out here and flashing. To generate an event though, if you double click in this drop down, it makes a method called the ID of the control underscore the event. So this is why it's important to name your controls. You don't want to leave your controls with their default names. You want to give them good names so that you know what is the control that's generating the event and what is the event. Remember that there's always a little bit of code that's being generated in addition to what you're seeing. So if I were to kind of go into here, remember last week I kind of showed you how to dig around a little bit? And if I click on this Form 1 Designer and it says Windows Form Designer generated code, if I expand this out, I could see that on the key down here on line 43, on the key down event, it says run the method called text username key down. Point being, there's a lot of auto-generated code for you. So when you generate an event, however you generate an event, watch what happens. Watch what happens if I just delete this. This used to break. Did you see what I did? All I did was I went into my code here and I said, oh, I didn't mean to generate that event. I just deleted it. Notice this little gray thing here said there's one reference. That means the code that was auto-generated right here on line 43, it's referencing that method called text username underscore key down. So if I just come into here and I delete it, this error is saying, wait a minute, that code that was auto-generated, it's looking for a method and you deleted that method. So this is going to be something that you probably run across, right? And so the way not to do it is do what I just did, right? Because if you have a reference to a method, you just can't come into the source code and delete it. Instead, what you can do is you can kind of come into here and delete it this way. When you delete it this way, watch what happens. If I just backspace this and delete it, and now I hit save all. Okay. Now this says 0 references. Right? You see that little number went from 1 to 0? Now if I reload this, yeah, now that's not there, because remember that was like a key down. That's gone. That line's gone. Line 44, whatever it is gone. So it's touchy. It's sensitive. You gotta do things the way that Visual Studio wants you to do them. Okay. Yes.
Can you go over how you deleted it?
Yeah, I'll do it one more time.
Yeah.
So let's say this is the one that happens all the time. You double click the form and you generate a Form 1 load. Oops, I didn't mean to do that. I didn't mean to generate Form 1 load, so I'm just going to come in here and I see that this kind of starts here and I delete it, and now I go back to my designer and it's broke. All right, oops, I can't do that. Control Z, undo, bring it back. Okay, now my form's loading again. Okay, so what you do, remember all of your controls are over here. Let's select the form and let's go to the events, the lightning bolt. And then I could see that this event was generated, Form 1 load. So I'm just going to highlight that and I'm going to hit delete. I'm going to hit save. And then I can come back here. Now I can see this goes from 1 reference to 0 references. Now I can delete this and not a problem. Okay?
Could you do it the other way around, where you deleted what you just deleted and then deleted from the properties or the event menu?
Walk me through this. So I'm going to generate Form 1 load.
Yeah.
And I'll just go straight to right here and just delete it straight.
Is that what you did before? No. Do it the other way, like where you.
He's saying, can you break it first and then go to properties and backspace it? Like that.
Oh, okay. Good question. So can I break it first, like so?
Make a reference, yeah.
Okay.
And then fix it while it's.
And then fix it in design.
Yeah, you can't do that.
No, you can't do it. You can't do it the same way. Oh. Now another quick fix is if you go here, you can actually click this, and it shows you the line that is the problem. This is the reference code, if you will. Check this out.
You just comment that out.
Comment that one line out. That's another hack, if you will. Okay? This is, yeah.
I got you.
Is that considered like hacky if you just somebody's going through your code and you just commented a bunch of stuff up?
I would not do that most of the cases, yeah, because what probably is going on if you just do this method, there might be some other code that's just kind of left hanging that's not really being used, right? So
then should you not just like delete that line of code?
you could delete it.
Right, because if you're commenting stuff out, is that still taking into account how big the file size is, even if you're commenting it out?
In different versions, so there's like the debug version and then there's the release version. So yes in one version, no in the other. Okay, so that's, each control has a default event. Like for a text box, for example, if you double click a text box, the default event is text changed for a text box. So anytime the user changes text, it's going to be running this event. However, there are many events for this text box, and I can scroll up and down and show you that there are many other events. So every control has the default event. You could work with just default events, but you could also alternatively work with any of these other events. These are common ones, right? So buttons have clicks, double clicks, the mouse enters, the mouse leaves, the form loads, the form closes. Closing is the process of closing. So what do you want to do during closing? You want to prompt the user, do you want to save your work? Right? Closed runs literally just after. So closing is the process of closing. Closed means that form is gone. So it's two different events. Yeah.
So then are you limited to all the events that it shows you? Or like hypothetically could you like code up your own?
Great question. Absolutely, you could code up your own. In fact, I think we cover that later on in this book. How to make your own events. And so an event is a generic, kind of like an object is a generic thing. An event is a generic occurrence. And so whatever you think could be an interesting event, one of my favorite events, I was on a website. Remember, Google has a bunch of interesting events. You can go to Google and search do a barrel roll, and that will cause Google to do an event, respond to an event, right? You guys know what I'm talking about? Yeah. Google do a barrel roll. This is like straight up 20 years old, but
I didn't know that.
What other ones does Google have, right?
I thought there was one that like turns into like a platformer game.
I know if you type I don't know if this works anymore, but before you type Atari Breakout and you go into images and it turns all the images into like the one game where is the ball breakout.
Atari Breakout?
Yeah.
And then images?
I don't think it works anymore, but
oh, okay.
You used to be able to do it like you see on the photos.
Okay.
It was like pretty fun.
There are events, and events can be whatever you want them to be, whether they're queries on a Google search or, hey, I remember there was a website that used to, the Konami code. Who wants to help me out, my gamers?
Pop up, down, left, right. Sorry.
Thank you. You would go onto a website, you would enter the Konami code, and the website would respond with 100 extra dollars on a coupon code or something. See what I'm saying? An event is whatever you want to be interesting. The user does something. The user interacts a certain way. You can make your own events. The answer, Ryan, yes, you can make your own events, whatever you want them to be, including the Konami code.
Try typing in Google in 1998 yet?
What do I type in?
Google in 1998.
Google in 1998? This is the most important part of our day. Google in 1998.
Oh man.
Nice.
It's like a watermark almost. I code in like a little event to every website you created or something.
I remember this.
I'm super proud of this, not really, but one of my early coding, my school gave me control of their website, not complete control, but some control in high school. And so in high school, they gave me control of like the basketball team, and I got to put photos on the website, and also I had the cheerleaders. And so on the cheerleading page, if you were to click one of the cheerleaders' shoelaces, she would jump up and say, "We love Evan." That's how mature I was in high school. There you go. So yes, event-driven programming. Very important stuff. Google in 1998. Remember the old "I'm feeling lucky" button?
Yeah.
Oh yeah. Netflix is doing that too, kind of like pick something.
Interesting. Yeah, just pick something for me.
Yeah.
That's right. That's right. So an event can be whatever you want it to be. You can make your own events. Now the methods, so here's a programming term. The method that responds as a result to an event is called an event handler. Okay? So these little fellas right here are called event handlers. Okay? The code that runs right here on line 43 that says when the mouse enters, run this event handler. Okay? This is a little bit of what's called wiring an event. That wires the event, the enter event, to a method called text username underscore enter. So there's event handlers, which are just, event handlers are just names for a method. By the way, for my new students, you're going, method? I don't even know what a method is. A method is just a block of executable code. So a block of executable code is a method. Methods have parentheses. These are my parentheses right here. Anytime you see these parentheses, you should think that's a method. Okay? What do I mean by block of code? Well, a block of code is anything in curly braces. So lines 33 through 35, this is my block of code. It's just a code chunk. So methods are blocks of code that execute when you tell them to. Methods that respond to events are called event handlers. The code that links events to their handlers is called event wiring. Terms. All right. Okay, they're talking about click events and all this kind of stuff. I'm just gonna whip something together real quick. Okay, I'm gonna do an empty form. We're gonna make something up. What like a simple math problem. Give me a simple math problem.
5 times 5.
5 times 5. Okay, here we go. How about number times number?
Okay.
Okay, we'll just do simple multiplication. All right. So we'll do a text box. What do we need for it? We need to allow the user to type in 2 numbers. I'll copy that and paste it. So the first thing I'm going to do, I recommend this for all of you. When you add a new control and you're going to reference that control in code, you give it a name. I'll call this text number 1. When you have individual numbers that are going to be multiplied, are those given a specific name? Like,
What was it?
when you have numbers that are going to be multiplied together, what, like, is that individual number given like like if you're adding numbers, I think it's called, like, this is an addend. Whatever. Text number 1. Let's go to this text box. I'm clicking this text box. We'll call this text number 2. So the name of our 2 text boxes are number 1, txt number 1, txt number 2. I'm just going to have a label here that's a big X. Now, I'm not going to reference this label in code. Everyone, so since I'm not referencing this label in code, I'm just going to leave it with its default name of label 1. I just want the user to see the text of an X. So I need to change the text. It's a big X. And even in here, like, you might go into the font and make it a big font or something. So here's font. And I'll make it like 18 in bold. Right, so we got this number times that number. And then I'm going to make a button called multiply. Nice big button. Multiply. I'm going to double click the button. Now, again, anytime I reference a control in code, you should name it. So the mistake that I made here is I didn't name my button. Notice it says button 1 _ click. I don't like that. I would recommend you not doing that. Okay, so I need to refactor this. Anytime you have code that's written and you got to rewrite the code, that's refactoring. You're rewriting the code. You're trying to rewrite the code better. So what I'll do is let's change this button name to button multiply. Here's what I'm going to do. I'm going to delete the event. See here, button 1 click. I'm going to delete that event. Then I'm going to come in here. It looks like it auto-deleted it. This has 0 references. I'm going to delete this one. This has 0 references. I'm going to delete this one. Okay, now I'm going to name my button. So this is how we go ahead and refactor our code. This will be btn multiply. Now when I double click the button, now it says button multiply _ click. I like that better. We're going to multiply some numbers. So we got to think about our data types. The question is, do we allow the user to have whole numbers or do we allow them to have decimals? I don't know. Do you want to allow whole numbers or not? Or decimals or not?
Well, if it's math, probably both.
Yeah, we'll do both, right? So what are our data types that allow both? Data, what's that?
Floating.
Floats. Yep, floating point numbers. So in floating point numbers, we learned about 2, right? One of which was a float, one of which was a double. Remember? So what's nice about floating point numbers is they can store both. They can store decimals and whole numbers. Okay, so let's go ahead, and for this demonstration, we'll store a double. Double number 1 equals text number 1 dot text. Got red squigglies. Why do I have red squigglies here? Let's take a look. Hover. Cannot implicitly convert string to double.
It needs to be like a number.
It needs to be a number.
It can't be a string.
How did we learn to convert strings into doubles?
Convert to.
Convert to, correct. So we would use this convert to double. Now let's break this down a little bit more before I do this. What do I have on the left? I've declared a variable with a data type and an identifier. The data type is double. Identifier is number 1. So the declaration declaring the variable is on the left. You give it a data type and you give it an identifier. Assigning a variable is whenever you do the equal sign. That's called the assignment operator. Anytime you assign a variable, the data types have to match. As Ryan said, we've got a string over here because the text, by the way, that's called the text property of the text box control, which is an object, right? But we said, hey, we need to convert this. Convert to double. Now we don't get red squigglies. If you know how to do it for number 1, do you think you know how to do it for number 2? Double number 2 equals convert. Visual Studio is pretty smart. Once I've done it once, Visual Studio is figuring out how to do it a second time. we're making a third variable called multiplied equal to number 1 times number 2. Let's go ahead and put a label out here for the result. Properties of my label. We'll call it label result. The name of my label is LBL result. The text is empty. Label result dot text equals. Now what I like to do is a string dot format, because again, we got a string on the left, we need a string on the right. And string dot format will take whatever you give it and put it into a string. And so here we can do our placeholders. 0 times 1 equals 2. Remember, 0, 1, and 2 are just placeholders for number 1, number 2, and the variable multiplied. So I'm putting my 3 variables into these placeholders. So this will say the first number times the second number equals the variable multiplied. So in the first, I said 5 times 5. This says 5 times 5 is 25. Let's go ahead and pause. You guys do the same thing, just another operator instead of multiplication. Just practice this. You can do multiplication if you want to just follow along with what I did, but you could do division, you could do subtraction. Just pick a simple operator. I'll pause the recording. You guys practice. Okay, we are going to go just kind of resume a little bit, and you'll see the more you write, Visual Studio tries to complete your code for you. It's like the perfect couple. We complete each other's sentences for one another, right? That's called IntelliSense. That's Microsoft's built-in coding assist features. So they give it a fancy name called IntelliSense. And so as you start typing LBL result, you got this little gray, and it says press tab to accept. You know, they try and figure out what you're trying to do. IntelliSense has gotten much smarter over the years, but that's just a code assistance type. Let's see, feature. Again, if you accidentally double click a control, like let me double click this text box, I generate this event that I don't want, right? Remember, the appropriate way to delete this event is by going to the properties window, clicking on the lightning bolt to go to its events. Go to the text, go to the text or drop down box. Just highlight it, delete, 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 delete. Delete that out of there and click the Save All button. And then most of the time it'll just delete it, it'll intelligently delete it for you. You want this to say 0 references before you can actually come in here and just delete it without it breaking anything. Okay, the different event handlers. Again, we talked about an event handler being a method that responds to an event. Let's take a look at some coding rules. Use spaces to separate the words in each statement. So kind of go into here. You could kind of cram things together a little bit. Even put multiple things on one line. First off, no one likes horizontal scrolling, so don't do this. You see how crammed up this becomes?
Yeah.
Right? So it is easier, you know, not easier. There are ways to write code that are easier to read. Okay, so some things, just kind of glancing at the code that I wrote, you know, look, you can include spaces some places, you don't have to though. But generally speaking, it's kind of like English, right? You want to separate your words. A little bit easier to read versus it all run together. You notice inside my code block, between lines 23 and 34, every line is tabbed over. So inside of a block of code, you tab. The more blocks of code, the more tabs over you have.
White space.
It's white space. Yep, that's your white space. It's the same number of, you know, this tab is how many spaces? 1, 2, 3, 4. 4 spaces. Our variables here follow a convention. What's that convention called? Camel casing. The opposite of camel casing is Pascal casing. Take a look. Form 1 and form. That's not Pascal casing, or that's not camel casing, that's Pascal casing. So our classes start with capital letters. Keep in mind that as we're dragging and dropping things from our toolbox, we're creating instances of classes. So the form itself is a class. In fact, if I hold down Control, this becomes clickable. And you can inspect the class called form. So this kind of took me into the form class itself, and here you see line 23, public class form. And you can actually dive down and look at all the code that's available to overwhelm yourself. But just to say, our classes don't follow that Pascal casing. Our classes follow, our classes follow Pascal, not camel casing. So what does this bullet say? Use exact capitalization. Tyler pointed that out to me earlier. He said, I got this red squiggly. He goes, is it because of my variables, you know, they're not capitalized the same? And it's like, yep. Capitalization it's case sensitive. So for example, notice here it's capital O-N-E, number 1. What happens if I don't capitalize it down here? Clayton?
What? Capitalize on that? I don't know. What's the capitalization?
Yeah, it matters. That's all I'm saying.
Right.
So what happens also if our text box is called TXT? 3 letters to abbreviate the control, TXT. I've seen a couple times already people saying TEXT. TEXT number 1. That's a mistake. You name it one thing here, then you go to reference it here. Wow, that's smart. It updated for me.
Oh my god.
It used to not do that.
That's not following camel casing.
Well, it's
It is.
lowercase. What would always confuse me about camel casing, maybe it just happened to you. I don't even want to say this because it confused me. Camels have tall heads, and then the neck goes down, and then there's a hump.
Yeah.
So when I think of camel casing, I think the first letter is caps because you start with the tall head. That's not right. Camel casing actually starts with lowercase letters. Did you just think the same way I did?
No, I was thinking.
Okay, good. Now I just screwed you up. Forget I ever said that.
No, I was just saying, like, we always abbreviate, I guess is what I was thinking. And so, like,
That's right.
not abbreviate.
So what's the abbreviation? That's a convention.
Yeah.
That's a convention, just like camel casing is a convention. So we do want to follow the convention of 3 letters abbreviated for the control type, followed by capital letters every new word. Visual Studio is too smart for our own good. Maybe not. So let's put spaces back in here. So back to our rules. End each statement with a semicolon. A large part of learning programming is where do the semicolons go? There's a semicolon at the end of line 27, at the end of line 28, at the end of line 30, and at the end of line 32. The semicolon is the equivalent of a period in English. It's the end of a statement. You make a statement in English, you put a period. You make a statement in C#, you put a semicolon. So just like in your English class, you had to learn where and when to put periods. In C# class, where and when to put semicolons. Okay, and blocks of code are represented by curly braces. Beginning of the block, end of the block. This is the block. Okay, as you get errors, you get this little error window down here. So yes, it's nice that there's a red squiggly, but there's also an error list down here. This one error says line 32. You can even click the link. This is a link right here, and it'll give you a little what's going on with the help in Microsoft Documentations. So you can go into more details. But it literally gives you a line number. Now, generally speaking, the line number is the approximate area. It's not always exactly the line. Okay, so that's a rule of thumb. This is the area in the code that the compiler thinks is causing a problem. Okay, so this is one example of more readable code. This is an example of less readable code. There we go. Here we go. True story. I worked with a guy who lost his job because he could not write code in a readable format. Instead, he wrote code like this. True story. He was a contractor. I worked with him, and you know, I don't know how many times he was told, but it just nowadays Visual Studio is actually pretty smart, and there's built-in tools that'll help you format your code in like a pretty consistent way. In our last class, it was called Beautify, right? And there was a plugin called Beautify, and Beautify would style your code in a more readable format. This is not readable. This is more readable. Okay, white space and tabs and things like that.
What language were you guys programming in?
C#.
Oh.
Yeah, my first application literally that I ever wrote was in C# in the early 2000s. Little did I know that I was pretty fortunate to be writing C# shortly after it was released. So indents and spaces and blank lines, these are all things that make your code more readable. And here's a little note. As you enter code in the code editor, Visual Studio automatically adjusts the formatting by default. That's nice. All right, let's take another break. So we left off on around slide 27. Comments. Comments are useful for documenting your code. Okay, comments are not really there for performance or anything like that. They're just there to provide useful commentary to other developers. Now, comments are good for you and other developers because a lot of times if you're writing some complex software that's got some complex math and complex problem you're solving, you want to write comments not only for other people, but you want to write it for yourself, because do you think you're going to remember how you solved that problem a month later? Right? So to say, oh, you should write comments for documentation for other developers, yeah, that's very important. It really is. But I think it's more enticing to say, hey, I'm going to write comments for myself, so that when I come back to the code that I wrote, I can remember what the heck I was doing. Because I don't know about you guys, but I tend to do something and then you kind of forget about it and you move on. You come back to it. You want good documentation. Comments can also be used to troubleshoot. Like here, this little button right here, comment out the selected lines. See that? You can just throw in quick comments. But like if these lines were causing an error to break everything, and it's like, hey, I just want to see how my code runs without it. You could just comment things out for troubleshooting. So comments are commonly used for documentation and troubleshooting. So you can comment out code, comment in code, just take out parts that are problematic and see, if I've got all these lines and for whatever reason something's breaking, I could just comment out this line. What happens if I just comment out this line of code and troubleshoot? Try and fix the problem. There are also multi-line comments. So these are single-line comments, just the 2 forward slashes. There's also multi-line comments that just go like that. / star to start it, * / to end it. So this is called a multi-line comment, right? And some developers get real fancy. They're like, oh, look at this. Like it makes it very visibly a comment. And you throw in all these extra stars and all this crud. Not necessary, but it kind of visually like screams, comment.
Is there a button somewhere that will show you all the comments in code?
That's a good question, not to my knowledge. That's a good question, not to my knowledge. There's not just like a find for comment. Control F would probably be your best bet. And just find all the double forward slashes. R / star. But no, I don't know of one tool that like summarizes them all for you. So that's all the comments. Commenting outlines of code. Okay, that's just a text description of what I just demonstrated. You did see that when you start having all these blocks of code, you can start, Visual Studio will kind of pick up on, oh, I can expand and collapse these different sections. And so Visual Studio is pretty good at picking up blocks of code and making them collapsible, and they even have these region things that kind of help with that. So you start a region and end a region. But you'll see that a little bit in Visual Studio. Then we got some more IntelliSense features.
I think you just closed your Discord.
I closed my Discord. Thank you. Just drag that over there. There are also snippets, and so if I open up right click, snippet, insert snippet. And so maybe I click on C# snippet, and maybe I forgot how to code a while loop. You can say while loop, and they'll kind of insert what's called a snippet and just give you a little bit of syntax, if you will, for coding a while loop. So again, you right click, snippet, insert snippet, C#, maybe class, and there they insert a snippet for a class. I don't really use that a ton, but they're there. And if I type in the word if, it says code a snippet for the if statement, note, tab twice to insert the if snippet. So I can hit if tab tab, and it inserts the snippet as well. So I'll do that like a lot. I'll say for tab tab and get a for loop. So tab tab is a snippet, and another one that I use quite often in this class is prop tab tab. So prop tab tab, this is a property, and we'll be typing prop tab tab quite a bit when we get to a certain point in the class. So tab tab, insert snippets. All right. Let's bring this back here. Let's take the comment out and talk about refactoring in our code. Number 1 is a variable. Notice that I declare number 1 on line 28. I use it in a calculation on line 31, and then it's part of my output on line 33. Okay? So if I were to change number 1 to, I don't know, maybe I need to change it to this. For whatever reason, notice that breaks it in 2 other places. So that is not the proper way to refactor. What you can do then, right click and go to rename. And now notice it kind of goes green. And now when I change it to number 1, it says rename will update 3 references in 1 file. I click apply, and it changes it in all 3 locations. So that's really efficient because, yeah, when you only got it referenced 3 times, it's not hard to change it 3 times. But what if you're using this variable in all throughout the darn code, right? It's in your best interest to right-click, rename, click apply, and then it's going to change it everywhere it needs to. Yes?
Does that change the property name, or does it only change it in the code?
So the question is the property name. So this, the properties are like the text property. So this is just a variable. It's not necessarily a property.
Okay. You're right. I'm sorry.
Yep. Now the question that you were kind of hinting at though is like what happens when and remember Visual Studio was pretty smart. So this button was called btn multiply. Just throw an extra y on it. Just save it and then view the code. It actually did not automatically change it there. It actually doesn't break anything though. It's actually pretty smart. And so I should be able to, even though I changed the name of the button, 5 by 6, multiply, and I get the result. So that doesn't break it, but what you can do, if you change it here, you can also right click and rename here, and apply it as such. So again, let's just rename this to 1y, click apply, and then let's see if I go back to this, we'll delete that extra y as well. I think there's a way to actually get this preview changes as well, and it'll show you all the different places it'll change the name. Okay, let's talk about a runtime error. Someone pointed this out to me earlier, that what happens if you leave that empty, right? You get this is called an exception. An exception is just an error that happens during the running of the program. It's a crash. It's crashing your program. Like, we'll have to learn how to fix these, and we will. Well, there's a whole chapter on fixing these. Okay, the error says input string was not in the correct format, and if you kind of scroll over, it even tells you what line 28. This happens on the button multiply click, line 28. So let's go to line 28. Line 28 right here is crashing. So line 28 is crashing because it's reading the text and trying to convert it to a double. Well, what's in that text box? In that text box is an empty string. You can't convert an empty string into a double. That's not a number. So that's why it's crashing. This error is called an exception, and an exception crashes your program. If I were to start this in debugging mode, now notice all class long I've been starting without debugging. If I start it in debugging mode, then you're going to get a little bit more details about that exception in Visual Studio. So now I get some details that even in Visual Studio, you get this exception unhandled. And it's kind of the same error message, just in Visual Studio. And you could copy the details and paste it into a Google search and probably get some sort of Stack Overflow help. Got to be careful with this, but that's certainly something that can be done. But a lot of times you're just trying to read the error message and get a general sense of what's going on, what's breaking the program. And so this is the exception helper that they're showing here. Again, we got a whole chapter on exceptions and how to diagnose and troubleshoot them and what they are. But just so you understand what you're looking at when it happens. Let's talk about testing a project. So, by the way, when this happens, you'll notice this is actually in a running mode. And so this little stop button, you'll need to stop this to get it out of this view. When I click this little stop debugging, it kind of goes back to normal. So if I run this in debugging mode, and then it does, you can see diagnostic tools and everything else, and it does crash, right? It's still technically running until I click this stop button or off of stop debugging. Okay. Couple last things here, testing. Well, I said let's test it with 5 times 5. But we said, hey, let's make sure we get some decimals, 6.3. Like, let's test it with decimals, right? We tested it with whole numbers. Let's test it with decimals. Okay, we get some math. Now, what's the expected result? Is that the result that you expected when you said 6.3 times 3? Yeah. Right? So when you're testing your application, you're looking for bugs. And so you want to test it with all sorts of numbers, with all sorts of inputs. Because probably what your teacher's going to do, what happens if you do 0? Okay, that didn't break it, that's good. What input could you give that could potentially break it? Try and break it. That's testing. Oh, okay. Now we figured out how to break it. How do you account for that? We'll learn. We'll learn how to account for that. So that's testing. Debugging then. Debugging is different than testing. Testing is looking for bugs. Debugging is fixing bugs. Right? So you can be a tester. There are full-time professional jobs as software testers. You don't even have to know how to write code. You just got to know how to throw all sorts of inputs into a program and test their outputs. Make sure you're getting the right output. Right? What happens when the user does this and trying to break it? And finally, this has been a long lecture. We are done though. Last slide here before our objectives. There is something very useful called break mode. Notice this little gray bar over here? Looks like I could put a dot here on line 29. I'm clicking here on 26, 27, and 28. It's not letting me put a dot there. But I could put a line on line 30. Can't do it on 31. You kind of see where you're allowed to put dots. Can't. Ooh, looks like I can put it on 38. See, these are called breakpoints. Okay, it's really not necessary to have so many. But if you're trying to fix a bug you got in your code, these breakpoints are very useful. And what you do is instead of, again, you start in debugging when you're trying to hit these breakpoints. And I could say 5.1 and the letter A and click multiply. And you can kind of see the execution of the program stops when I put this breakpoint. And it's about to execute line 29. And if I hit this button, step into, you can see number 1 holds the number 5.4. And then I can hit line 30 and I hit that and it breaks. So this break mode is a way to actually step through your code line by line and troubleshoot. So breakpoints are very, very useful troubleshooting tools, but I would say it's a bit intermediate level, and we're not intermediate yet. So just exposure to it. You've been exposed. But that's what that is. That brings us to the end of the lecture. What I'm going to do for the rest of today is practice with you guys. Okay, we're not necessarily going to jump into a lab. It's going to give a programming discussion challenge. It's something for all of us to practice. We'll do it as a class, and then we'll do another one, and then another one, and another one. Okay, so I'll stop the recording here.